Greetings, we're going to talk about double angle identities, which means you've been probably working in a trigonometry or a pre-calculus class, and they're asking you to verify or prove something with a double angle identity. All right, now, so we're going to find the sine of 120 degrees using a double angle identity. Now, there's easier ways to find the sine of 120 degrees. If you're familiar with your unit circle, you're just going to find your reference angle and use what you know about 30, 60, 90 degree triangles. But we're going to verify with the double angle identities. These identities are going to be really helpful to us when we go to solve equations that have trigonometry functions in them. So we're just understanding the basics of them right now. So this is the identity that your instructor will have given you or shown you reference to in your book or online. Basically saying the sine of 2 times an angle is equal to 2 times the sine of that angle times the cosine of that angle. All right, so this 2u is why we call it a double angle identity, the sine of twice an angle. All right, now your book could have theta or x or whatever variable they're using. The one that I use just happens to use u as a variable. All right, so let's set this up. So in this case, 2u in this problem is equal to 120 degrees. So 2u is equal to 120. So what does that make u equal to? Well, you'd solve this simple algebra problem and you'd get u is equal to 60 degrees. All right, so think of this formula now as saying the sine of, another way to rewrite 120 is 2 times 60. All right, so the sine of 2 times 60 is equal to this right-hand side. It's 2 times the sine of 60. Cosine 60. Excuse me, I'm writing with a mouse, which I'm still not very good at. It's not the best writing in the world. All right, so we basically figured out what u is for this problem and substituted it in for this problem. So we're going to clarify this. So a 60-degree angle, if you're watching this video, you should be familiar now with the unit circle. All right, so we've got a 30, 60, 90 triangle here. So our reference angle is 60. You should know that the side of the triangle across from 60 degrees, the length is square root of 3 over 2. And then the side that's across from the 30-degree angle is always 1/2 when you're dealing with the unit circle. Okay, so in this problem, 60 is our reference angle. Remember, on the unit circle, x is cosine, y is sine. All right. So in this case then, we have 2 times the sine of 60. Well, the sine of 60 is square root of 3 over 2. Times the cosine of 60, which is 1/2. Multiply these 3 numbers together. You'll notice that 2 times 1/2, those are reciprocals or inverses of one another. And when you multiply them together, you get 1. So 1 times square root of 3 over 2 is just square root of 3 over 2. All right, so we've used a double angle identity to show that the sine of 120 degrees is, in fact, square root of 3 over 2. So when we started, I said, you know, there was a quicker way to know that. 120 degrees on your unit circle is right here. So it also forms a reference angle of 60 degrees. And remember cosine sine on this, so it would be a negative 1/2 and a positive square root of 3 over 2. So just by using our unit circle, we knew that the sine of 120 degrees is square root of 3 over 2. All right, now let's do a second example. All right, see if you've got the hang of it. All right, in the second example, we're going to find the cosine of 4 pi over 3 radians. All right, so if it's helpful, convert radians to degrees. One of the first things you should have learned in this trigonometry section was how to do that. Okay, so we'll take radians, we're going to multiply by 180 degrees divided by pi. All right, now pi divided by pi is just 1, so think of those as canceling out. So you could multiply these together and divide by 3. You could cross cancel. 180 divided by 3 turns out to be 60. So 60 times 4, we're dealing with a 240 degree angle in this problem. Okay, so you could use what you know about the unit circle to figure out what the cosine of that is. But we've been asked to use a double angle identity. All right. So we're going to use, this is the double angle identity for cosine. Now there's different forms of this cosine double angle identity. Your book will probably have 3 different versions of this because it's related to the Pythagorean identity. I'm not going to go through all that right now, but I'm going to choose this identity here. All right. So again, we have to figure out what u is going to be. Well, if 2u is equal to 240, so 2u is equal to 240. We're going to divide that by 2. We're going to find out that u for this problem is 120 degrees. Okay, well, we just kind of talked about 120 degrees. Its reference angle is 60. Okay, so 120 degrees is 90 and another 30 puts you here. So it's 60 degrees back to the x-axis. So our cosine sine for this triangle is a negative 1/2. And our sine would be square root of 3 over 2, which we kind of knew from up above. All right, but again, we're going to use our identity to prove this is true. So now we're going to say cosine of double 120, that's why we call it a double angle, is equal to, all right, the cosine of that 120 okay, once we figure that out, we're going to square that minus the sine of 120. And we're going to square that. All right, so here's our 120. When you're doing trigonometry, always draw your little unit circle triangles. It'll really help you visually understand the problem. So the cosine is negative 1/2. Now if you're doing this on a calculator, you better wrap that negative 1/2 in parentheses when you square it, because the negative times the negative is going to be positive. And our sine of 120, we knew from up above, is square root of 3 over 2. And because of our identity, we're going to square that. All right, so negative 1/2 times negative 1/2 is a positive 1/4. All right, and we're going to subtract square root of 3 over 2 squared. All right, remember when you square a fraction, you have to do both the numerator and the denominator. Square root of 3 times the square root of 3 ends up just being 3. And then 2 times 2 is 4. So we get 1/4 minus 3/4. We already have a common denominator there, so we can just subtract those. We get negative 2 over 4. Negative 2 over 4 is the same as negative 1 over 2. So the cosine of 4 pi over 3 becomes negative 1/2. Using a double angle identity. Now again, we talked about the fact that I could have, what I know about the unit circle, I know that 240 degrees is 180 plus another 60, right? So it puts us here on our unit circle. Okay, what I really should do is so we know that the reference angle is 60 degrees back to the x-axis. So again, we're dealing with a 60-degree angle. So cosine for this is going to be -1/2, and the sine would be negative square root of 3 over 2 if you're talking about 240 degrees. Okay, so we know that we just used a double angle formula to verify that this cosine here for this angle is -1/2. All right, hope this helps. It's a video, so if I went too fast, feel free to rewind, pause, repeat as many times as you need to. Thanks for listening.